Thanks, guys. And first of all, I have a question. Do you enjoy the conference so far? Yeah. Wow. Yeah, that's actually bad for me because it makes me responsible to not mess up your impression. Okay, so let's dive in. And I will say that I am like the last boss, and I know that I separate you from the closing dinner, so I won't use my superpower of delaying the talk for an hour. And I'll start right now. Yeah, my name is Dmitry. I'm doing a lot of open source, and I am working at Lightsource.ai, and we are doing something really interesting. We're doing the whole end-to-end supply chain and procurement stack in Rust, from GraphQL, endpoint, and API to artificial intelligence and like data processing and analyzation. So if you're interested, just let me know. You know where to find me. Okay, but today I'm going to talk about my different passion, and it's actually videos. I'm really obsessed with everything that you can touch, feel, visualize, or hear in the programming. And actually, videos are really important type of content for current society, right? According to statistics.io, people are spending more than 10 hours per week. It's dozens or hours of billions hours watching the videos. And by the way, did you understand how we appeared in the world where this is the correct type of the video, the vertical one? I don't. And actually, somebody is making this video. Somebody making tons of videos. But the technologies behind the videos are completely outdated. And I'm even not talking about like professional software, but we should actually. We're talking about some free-to-use software, maybe mobile APIs full of IDs. And there is a big problem. And the problem is JavaScript. Yeah, I have no idea how JavaScript became the popular for video rendering, but people are really making videos in browsers. But actually, that's not all. The Adobe After Effects, the most popular software, the most professional software for making animations and graphics, actually runs plugins over JavaScript. And that's crazy. Like people spending 20,000 euros on Pro Mac computers to have a bottleneck in running JavaScript. That's like, yeah, that's bad. And we together are responsible to change that because it's time for us. It's yeah. Thanks a lot. And always has been because yeah, memory management is like the most important part for videos and for media programming. You just can't use garbage collected language, and you can't have memory errors because they are really hard to spot. And today I'm going to talk about my journey of learning how to use Rust for media programming, and my journey of building framework for this. And I'll show you everything, but I'll firstly start from the scratch, from what is a video, how it actually works, and what is inside the video. And to be honest, videos are not really hard to understand. That's actually a sequence of images, nothing more. So you can say that we have an MP4 file, right? Like here. And MP4 is not a codec. It's an important statement. It's just a media container that somehow contains an information. And here we can see that media container can contain couple streams, like images stream, where each green pill is an image, but it's already encoded image with two numbers. That's all you need to know about images. The first number is presentation timestamp. The second number is the decoding timestamp. So basically, that's just a giant binary file where every image is also a buffer, and your codec is responsible to read it and decode it correctly. So for example, if we have decoding timestamp, like they're not in order, so the codec may need to encode, like for example, here we can see the fourth frame being needed to decode it before the third one, and so on and so forth. That's a magic of codecs. We'll return back here. And we have also an audio stream. An audio stream is a completely different thing. We capture audio in samples, and we have like, this 44,100 samples per second, and we also break it inside the frames, which are usually like 1024 or 512 inside the frame. And it also has the presentation, decoding sometime, and when the player reads this file, it synchronizes the content and it actually plays. Nothing really hard until you figure out how much codecs there are and which one is correct. So basically, if you want to encode your video, you need to use a codec, and there are a lot of different codecs. Some is like useful for professional video editing, some useful for streaming, some useful for something. Do you hear me better? Okay, perfect. Okay, I'll grab my clicker. I forgot it. So you just need to somehow encode your images into the video. And how you will do this? Because the codecs are not like software. It's actually a specification. So the HEFT is the high efficiency video codec, or H.265, has a specification over 700 pages. And you don't want to deal with it directly, right? You don't want to implement this because it will take 10 years for me to make this on weekends. But you can use the project called ffmpeg. And you have all used this, I'm very much sure. And this is enough, and this is what people are using to make videos. So we can generate a bunch of images somehow. An example is browser, which just runs the headless browser, and then saving the screenshots with a specific pattern, like pic, then the number of frame, and the PNG. So what is YUV image? It's the most popular image that stands for video production for decades. And what is it? It's just like regular image where the pixels are split to the luma channel, the brightness, and the red and blue projections. When you combine it, you get the real image. And yeah, that's just an interesting story where it came from. It came from analog television, where the companies discovered that they want to sell people the colored television. They didn't want to make a breaking change. They didn't want to introduce something new. So they created an algorithm, a new video structure that sends 2 additional channels. So people who want to use color television only need 2 additional channels. And that really worked well. We all know that color television succeed. But right now, for everything that touches the video, we need to do something like this for each frame. And it becomes a problem. So this is a copy from my framework that takes the RGB image and sends it and converts it to the YUV or CBCR channels. There's some magic inside. And if you want to copy it, just make sure that you follow in examples, because C libraries may be crazy and they just can sometimes read every sequence byte, sometimes read every 4th byte from the data source. So we need to be exactly sure that we are using it as designed. But right now, you know that you can actually take any kind of image, you can decode it, you can get the raw image sources, convert it to YUV, send it to the encoder, and then get a video. Okay, that's fair. But right now, we need to actually somehow render images. And that's becoming a problem, because how you will render images? Maybe somebody has some proposals? No, not a lot of proposals. And the problem, again, yeah, fragment shader. That's a nice proposal, but it stands for, yeah, let's get back to this later. I'm talking about this. So basically, if we want to render some images, the most popular today is browser. The browser stands today for everything. People are using browsers for everything, but that's not our option. And the problem is that it's becoming really crazy. Can you spot the similarity between these 2 images? The first one is the obvious streaming that streams on Twitch and has some notifications on the UI. And the last one, it's my GitHub repository and SEO image generated by GitHub. They both render it in browser. The OBS used in browser to render all the UI when streaming, and the GitHub is also using browser to render its previews. But that makes literally no sense. Why do you need so much browser everywhere? I have no idea. So I started thinking of what we can use instead of browser. And what we need to actually have some fixed, animatable, friendly for developers, GPU first, and important to understand that it should be understood by developers, debuggable and clear, because nobody wants to learn new additional language in order to generate some video. And it always has been a frame and format that perfectly supports all the edge cases. It's SVG. And do not be scared. SVG is not what you're thinking about. Thanks. So SVG can contain not only these scary pauses with a lot of like weird things that even I cannot understand, and I made a parser for SVG. It contains like literally all the required primitives, some basic shapes like rectangle, ellipse, circle, text with the different font families, images, and even foreign objects that you can actually customize as you need. So the SVGs, like it's just perfect fit for video rendering because SVG defines how to render images, and we actually need this. And let me introduce you my framework. It's fframes. I'm working on it for 1.5 years. And right now, I will try to describe how I combine all of this like knowledge together to make it end-to-end Rust solution to actually produce the final video using SVG and all of this stuff we just learned. So let's start. So basically what you want to, if you want to make a program that makes a video, you want to have some input. Let's say it's a very simple example. You have a slug of a string. You have the implementation of trait for the video, which has FPS, width and height, the dimensions, and the speed of the rendering, the duration, which is 30 seconds. You have no audio, and you have some function that renders this particular frame. And the function that renders this particular frame looks very much like SVG. So you can actually just copy SVG somewhere and paste it here. What's important? Important here is this part. So basically, you can see that you have here the rectangle that starts on the 0, 0 position, takes the whole width and height of the canvas, and it animates over like timeline every 5 seconds from specific color with a bunch of different isms, like the liner, the Apple-like spring animations. You have the font family of text that goes next, the DM sans that will be resolved from your computer or from your media folder. And you have the JetBrains monofont for NASA text, which stands for displaying the index frame and the current second. And that's how you define the video. And that's what you are getting as a result. That's a development editor, which gives you an ability to preview the actual video. It works like in 60 FPS. It displays you the whole timeline. I bet you don't see the colors different here, but it actually it's there. You see the resources, the two fonts, and you see the preview of the editor. But what is more important, that you can actually open DevTools and you can debug your SVG. And that's actually an intention. The browser is like really the best thing to develop SVG today, and preview things in the browser makes it lightweight and make it easy to debug. So you can actually debug your SVG, you can change the arbitrary values here to experiment, or you can copy the SVG from the browser and paste it into Figma and design it in Figma, and then copy it back and paste again into the Rust code. Yeah, let's go to the next slide. And here is how it works. So the idea behind of the editor, so video creation app, is always, the problem is that you need to somehow preview it. And there was some breach that makes the editor live. It actually works perfectly. So we basically take the video definition that you see above and giving it to the some front-end client-side app that renders you preview with all the information and with all the calculations that you made inside the render frame function. So you actually make any kind of calculation, you can pass any kind of inputs, and you also can use a couple of core fframes APIs. Like animations you see. And also, for sure, we need another one backend. We need a renderer backend which actually renders you the whole file. And yeah, so the actually how you will include the wasm bridge, you just pop up the macro as for everything, right? You just includes macro, includes some inputs. I forgot to put here the slug, but yeah, that's how it is. Pretty much simple. But here is probably the most important part of this talk. It's the rendering problem. And if you want to avoid something like browser for rendering, it's becoming really tricky because you need to somehow analyze all the SVG. You need to somehow parse it, and you need to actually render it. And apparently, Rust community is so awesome. So when I started the project, there was already a re-SVG library that had 1.5 thousand tests that was built by Razor Falcon, and it just do what I need to do. So right now, if you don't want to use like frameworks, like my implementations, you can just take it and use it directly. But it doesn't have any kind of caching, and the rendering of video is very much like dependent on what you are, how you will reuse the rendered process between the frames. So I actually implemented something over the, oh my God, let's back it back, over this library, and created my custom renderer backend, which is like one for CPU and one for GPU. The most important part here is that we need to somehow also parallelize the rendering. And this is really hard because the rendering encoders are doing a lot of math based on the sequence of the frames. It is important for you to supply all the frames in order. So you can just use Rayon, split all the power iter over all the frames, render them, and supply. That will have literally no sense. You will not work, and you will also have mostly no cache hit between the rendering. So basically, how fframes is doing? The fframes actually creates like encoders by the number of your cores, in this case like 12 encoders, and mostly renders 12 different files in a specific order, so that after all, it just mostly concatenating the frames without any actual re-encoding. So basically, if you have like 12 cores, you will render like 12 videos into the file system, and then basically read the whole buffer of the file system and concatenate it with another buffer and render the final file. And that's becoming really, really performant. So in order to render something with fframes, you are basically creating the hello world video, which defines how you will render frame. You pass the output file, you pass some render options, like you pass which logger you want to use, which backend you want to use, and the preferred codec. And here is an example. I promise you it wasn't rendered with fframes. It's the real screencast from my computer. And it renders a full HD 30-second image where every frame is animated with some color, where you have on every frame where you have the different text per each frame in 4 seconds, which is actually faster than the browser will store it. But you know that I know that you probably expect right now to see the demo of the video, but if I will put the previous video that we defined, that would be really, really boring. So be a little bit patient, and I will show you something more interesting in a second. Okay, but the problem with CPU rendering is about these things. So basically, if you want to, it's not displaying at all, but if you want to have some shadows, or you have to use some gradients, or you have to blur something, CPU physically cannot render correctly this type of content because it involves a lot of one by one calculations per each specific pixel. So you need to or smooth the color, or you need to make a Gaussian blur, which is really hard, or you need to do everything together. And that's where GPU actually helps a lot. It's somewhat useless, I would say, because nobody will use GPU backend. That's my personal assumption, but that's really cool. And that's implemented from scratch. So the idea of GPU here is some graphs over rendering of the FPS, like frames rendered per second for CPU and GPU. And for this hello world video that we've seen definition a couple slides ago, the CPU wins because GPU can actually take one core. And the parallelizability of Rust actually makes CPU even faster. But if we make it 4K, CPU actually makes slow down. And if you have some blurs and gradients here, GPU wins perfectly. Unfortunately, supporting GPU involves a lot of trickiness, because right now we need not to only analyze the SVG and map it directly to the buffers. We need to firstly simplify SVG into vertices and indices. and the important part, the shaders, and to involve the actual GPU shader over the vertices and indices, then get the resources, then get the texture, and map it directly to the encoder, which makes it hard. And yeah, because it was not implemented, I needed to do this from scratch, and it's like really bad supported the whole spec. But what is really cool is that because of we are using Rust and we are using everything, we're building everything from scratch. I actually building everything from scratch. We are getting like benefits from using the whole end-to-end stack. So basically, because we know how you are parsing Rust code, we can introduce thing that I call cascade caching, which is probably not the best name, but imagine that you have some paths of SVG, which is the layer 1, and because SVG is always the flat structure and your all the elements cannot be nested, you always know that the next element overflows the previous. So we have the path, for example, we have the image, and we have some rectangle that animates with some animation. What we can do, we can actually compile it. We can actually run simplification and render it to the pixmap or to the vertices and indices ahead of time, right inside the proc macro. And that's what makes like the rendering really as easy as render like a couple pixels on a pixmap, and that what makes fframes really fast and really like ahead of time-ish, yeah, something like this. So basically, instead of having to render everything, you are caching independent layers or even shrinking couple layers and having only the base pixmap that only renders the last animatable element. And that's really easy because Rust provides the really awesome proc macro tool, and we can understand when it is linked to the some variable, or it is a constant which we can ignore, or it's something that we should animate. Okay, so you know that videos are not only about the actual images. It's also about the audio. And we can actually go crazy with audio, and we can do something like this. The pure mass, the very cool thing. We can just sum that mass, we can just like calculate the hertz for the specific, like the frequency for the specific time point, and you can create even music with code. We can be really creative, but what we really want to have is something like this. We want to have the preview, that is development mode, where you have all your audio tracks. They are mixed together,
Nothing
and it works
more
something like this.
than simple SVG.
Yeah, nothing really surprising. So basically, you get all the audio tracks, maybe some music background, maybe some voice, maybe some audio sound, and combine it together using the simple Rust API. And as a result, you're getting the one audio stream with the mixed audio. But what is really awesome here, that because we always load in the audio, we can provide user the API for gorgeous video, audio analyzation and spectrum analyzation to create audio visualization, just like new iPhone Dynamic Island. And that is really easy as well. That was actually the very first intention to build the project. I had the podcast at times, and I wanted to have this awesome audio visualization. And what I've done, so basically you just asking fframes to give you the audio data for the specific frame, and then it gives you the vector of the frequencies, which you somehow smooth. In this case, I'm using the simple decibels, the logarithmic decibels, smoothing, and render it as a rectangle with a specific height. Nothing more. And it works pretty seamlessly, and we had like podcast visualization rendering running for 15 minutes. That is really interesting and cool, and videos are really interesting and cool. I hope you think the same. And but you may ask me, so you talking about like videos today. You talked about the Rust, but where is the art? Where is the art? That's the main question. So I ask you to have an attention to the screen, and that is the art of programmatic videos in Rust and fframes in particular.
Welcome to fframes Beta, the very first Rust-based framework for motion graphic videos. Interested? In order to try it out, sign up to our Discord and send your GitHub to the beta channel. You'll get an invitation to our GitHub repository with all the source code and a couple examples to get started.
Thanks a lot. And I will feel a little bit like Steve Jobs. You can pre-order it starting from... No. The beta starts right now. The public beta starts right now, and the instructions available in videos are correct. You can right now sign up to the Discord chat and get an access to the GitHub repository of FFrames, try it out, or maybe play around with it. And I will be happy to help you support your work and everything related to the video production in Rust. Thanks a lot for your attention.